about potential energy. So there are a lot of different types of potential energy. The big thing to keep in mind, all potential energy is it's stored energy. So if you think about it, when they tell you, you've got a lot of potential to do something, you're going to go out and do stuff. If you have stored energy, then you're going to go out and you can do stuff with that. It's kind of the weird connection that I made. But that's all potential energy is. It's just stored energy. So a couple of examples for this. Smaller. So if we're talking about chemical potential energy, this is going to be things like gasoline, food, batteries are another example. You might think of it as electrical, but it's actually a chemical reaction that's going on inside of them. We also have elastic. Elastic potential energy. So you think about like bungee cords. Rubber bands. Bows. Getting on an archery bow, anything that's going to stretch when you pull it and then snap back. And then there's also electrical. So there's going to be like static charges. Like when you sit there and rub a balloon on your face or on your hair. There are other examples. Those are just a couple for us to go over. The big thing that we're going to focus the most on in this class is going to be gravitational potential energy. Stop moving that one. Or GPE. This is energy that is being stored due to an object's change in position. So what's its change in height, to be more specific. And so one big thing to keep in mind as we're going through and doing all of these different types of energy is they can all be converted from one type to another. So energies can be transformed. Into other types of energy. By doing work. Okay. So for gravitational potential energy, our formula here. So GPE equals M times G times H. Sometimes you'll see it as delta H. We talked about it the other day in our notes. Again, M is mass, which is measured in kilograms. Now we can put those two dots there. G is gravity. And then H is your height, which should be measured in meters. Again, gravity never changes for us. It's always the 10 meters per second squared. One thing to keep in mind is gravitational energy is always measured relative to a frame of reference. Or to a reference point. So for example, right now we're in the second story of a building. Some people would like, depending, like you're saying within this classroom, like you sitting there, you have no potential energy. Like if you fall, you're going to hit the floor. If you say in the frame of reference of the building, then you have to take in consideration that we are on the second floor. That's saying if you were to fall through the floor and keep going. So it's just all relative to what you're talking about. And they'll tell you something is this far above the floor or above a table, and that's usually what we're talking about. So if we look at our first example here, so we have a 15 kilogram textbook that is sitting on a 1.2 meter tall table. If the book is lifted 0.8 meters above the table, how much gravitational potential energy does it have? So the first thing we're going to talk about is in respect to the table. So when we go to draw a little picture here, and keep in mind this is not to scale, that's going to be our 1.2 meters. Our book is then 0.8. Make that look a little bit easier to read. 8 meters, I guess that's in meters. So first thing, all we want to know is just how much energy, how much potential energy does it have dealing with that space right there. So that 0.8 meters. So GPE equals M times G times H. So our mass is 15. Our gravity is 10. Our height is 0.8. So when we go to plug this in, you should get 10 times 15 times 5.8 is 120 joules. Now, if we take in consideration respect to the floor, let me draw this real quick. So respect to the floor, looking all the way down, it's going to be the 0.8 plus the 1.2. So it's going to be 2 meters off the floor there. So same equation, GPE equals M times by G times by H. Mass stays the same. Gravity stays the same. Height is the only thing that changes. And so now it ends up going to 300 joules of energy. And that's the other thing I didn't mention. Potential energy, same as work, is measured in joules. If we look at an archer with a bow, archer with a bow pulls back with an average force of 120 newtons. While drawing the arrow back a distance of 0.200 meters, we want to calculate the potential energy of the bow in the system. So we're going to look at what our change in energies are with this. So to start off with, we're going to say it has 0 potential energy to at rest because you're not pulling the bowstring back any farther. Its distance that it moved is 0. Because what we're actually using is our change in energy also equals our work, which also equals a force times by our distance that moved. When we go to look at this, our force is 240 times by our distance is 0.2.